if the effective value of the current is 50 Hertz and AC circuit is 5 ampere. So what is the peak value of the current? So the peak value means amplitude value of the current. So I amplitude, that is a current amplitude value is I naught. So IRMS, which is equal to I naught by root 2. So IRMS is I effective value. So I naught is equal to root 2 I effective. So the effective value of the current is given in the question itself, 5 ampere. So root 2 into 5. So which is equal to 7.07 ampere. Then the next question is the mean value of the current over a half cycle. Dear students, we have derived the expression for mean value of the alternating current for the half cycle is I max, that is a mean value, I mean value, which is equal to 2 by pi I naught. So I naught value we are calculated as a 7.07. Then we substitute here, instead of 2 by pi 0.637, so we get an answer 4.5 ampere. Then next one is the value of the current at time t is equal to 1 by 300 second. So we know that the instantaneous current value is I is equal to I naught sin omega t. Omega is the angular frequency. So we can write the angular frequency in terms of the linear frequency as a 2 pi f. So I is equal to I naught value 7.07 ampere. Then sin 2 pi f is a frequency which is given in the question itself. Then into time 1 by 300. So substituting all these values, we get an answer. Current I is equal to 6.12 ampere. Problem 2. A resistor of 50 ohm and an inductor of 20 by pi Henry and a capacitor of 5 by pi microfarad are connected in series. So it is a LCR circuit in series connection to a voltage of 230 voltage and the frequency is 50 Hz. Find the impedance of the circuit. So very simple. The given that we have a resistance of this circuit is resistor value is 50 ohm and inductor value and the capacitor value, even the E effective, that is applied voltage is given as a 230 voltage and the frequency is 50 Hz. So first, in order to find the impedance value of the circuit, what is the formula? Z is equal to root of R square plus XL minus XC. So first we have to find that what is XL and what is XC. So the inductive reactance is XL is equal to omega L. Omega is a 2 pi of L. So substituting the 2 pi F is a 50 Hertz and L is given as a 2 by pi F. So by doing this calculation we get 2000 ohm. Similarly, by using the formula capacitive reactance Xc, which is equal to 1 by omega C, so we arrive and calculated value as the same value of the inductive reactance 2000 ohm. So in this case the inductive reactance and the capacitive reactance are same, 2000. So when the XL is equal to Xc, what is this condition? Yes, very good. It is a resonance condition. So the impedance Z is equal to root of R square plus XL minus XC the whole square. XL and XC are equal. It will become 0. Then the circuit become pure resistive. Then this is an resonance condition. So Z, which is equal to the impedance value is only the resistance value 50 ohm. Okay. The next problem. A 25 microfarad capacitor, a 0.10 Henry inductor and a 25 ohm resistor are connected in series with AC source of EMF. They are given the EMF equation E is equal to E naught sin omega t. So E is equal to E naught sin omega t. Comparing this E naught value, the amplitude of the EMF is 310 and the angular frequency value is 314. So angular frequency is equal to 314. What is the first question? What is the frequency of the EMF? So frequency means linear frequency. So omega is equal to 2 pi f 314. So f is as it is. Then you have to bring the 2 pi in the denominator. By calculating this, we arrive the solution at the answer as the frequency f is equal to 50 Hz. So what is the frequency of the EMF? We can calculate by using this given equation itself. In the question itself, it is given. Then the second question for the same is second subdivision. What is the reactance of the circuit? So reactance means we have the two types of reactance, capacitive reactance and inductive reactance. So we have to calculate both the capacitive reactance and inductive reactance. Capacitive reactance formula is 1 by omega c. Omega is the 2 pi of c. Substituting all the values, we get the capacitive reactance value is 127.3 ohm. Then inductive reactance value is 2 pi fl. Substituting this 2 pi f value is 50 hertz and L values as it is given in the question 0.10, we get an answer 31.4 ohm. So it is very clearly the capacitive reactance is greater than inductive reactance. So this circuit is purely capacitive as XL and XC are in phase difference by 180 degree. So are you remember that XL and XC are in 180 degree? I will just recall you, this is a phasor diagram for XL is greater than XC. So for this also the VL and VC both are in 180 degree. So the VL is also 90 degree ahead and 90 degree this side. So both the value is 180 degree, 90 plus 90, 180 degree for XL is greater than XC or XC is greater than XL. For both the cases, the angle between the XL and XC or VL and VC is 180 degree. So net reactance is equal to XL minus XC. So the inductive reactance is 127.3 and the capacitive reactance is just I have changed that. So XC minus XL, because here XC is the capacitive reactance is greater than the inductive reactance. So we have to put bigger value minus smaller value. 127.3 minus 31.4. We get the net reactance is 95.9 ohm. That is what is the net reactance of the circuit value is this one. Then the next one is in the same question. What is the impedance of the circuit? Yes, very easy. Z is equal to root of R square plus into XL minus XC or XC minus XL. So here it is a XC minus XL because it is a pure capacitive circuit. XC is greater than XL. So we have to put XC minus XL. So XC means capacitive reactance, XL means inductive reactance. Substitute this value. So we get that it is a 95.9 ohm. So 95.9 ohm the whole square and 25 is a given resistance value. So in the question itself they are given the 25 ohm is a resistor value. So substituting these values we get an answer. The impedance of the circuit is 99.1 ohm. What is the current in the circuit? So the effective current which is equal to IRMS which is equal to ERMS by Z. I effective which is equal to E effective by Z. So E effective is equal to ERMS which is equal to E naught by root 2. So E naught value it is given in the equation itself. In this equation 310 is a E naught value, that is a 310 E naught value which is given in the question itself. Then root 2 approximately we get an answer 220 voltage. Then what is a current? So the question is what is the current in the circuit? So instead of calculating the current we have to know that voltage. So I effective which is equal to E effective by Z. This Z is a total resistance in this circuit, that is the impedance. So very simple students, what is the current? Current is equal to voltage by resistance. So voltage is a total voltage and resistance is a total resistance, that is the impedance in this circuit. So the answer is 2.222 ampere. Then the next question is what is the phase angle of the current by which it leads or lags the applied EMF? That means what is the phase angle, they will ask that. So this circuit is a purely capacitive circuit. Since XC is greater than XL, so we have to use a phase angle tan pi which is equal to XC minus XL by R. If it is a purely inductive circuit, we have to put XL minus XC. So what is XC minus XL? It is a net reactance value 95.9 ohm, then the resistance value 25 ohm. By calculating that we get an answer 3.84. Dear students, in examination it is difficult for you, so you have to write pi is equal to tan inverse of 3.84. They may give the award the mark for you. So the solution for this one, tan inverse of 3.84, is 75.4 degree or approximately 1.31 radian. This is the phase angle of current by which the applied EMF. Then what is the expression for instantaneous value of current in the circuit? So the instantaneous value of current can be calculated by using I is equal to I naught sine omega t plus pi. Why we have to put plus pi? This is a capacitive circuit. That means the current will lead the voltage. So by phase pi. So I is equal to I naught sine instead of omega 2 pi of t plus pi. So IRMS value is I naught by root 2. So I naught, which is equal to root 2 into IRMS. IRMS value we are calculated in this subdivision 2.22 ampere. So 2.22 ampere into root 2, we get I naught current amplitude value is 3.313 ampere. So I is equal to, instead of I naught 3.13 and sine, then the omega value which is given in the question itself 314 t plus, instead of pi I substitute that 1.31 radian here. If you are not able to calculate, you put as a tan inverse of 3.84 here itself. So we may get the correct answer. Then the next subdivision is, what are the effective voltage across the capacitor, inductor and resistor. That is voltage. What is the voltage across the capacitor, inductor and resistor? These three are connected in series as it is a LCR circuit. So V is equal to IR. V, that is a capacitor voltage, which is equal to total effective current into resistance in the capacitor, that is a capacitive reactance. So effective resistance is IRMS is equal to 2.22 ampere into the resistance of the capacitor is 127.3. we are calculated already. So the voltage value is 282.6 voltage. Similarly, for the inductor also, VL, which is equal to I effective into inductive reactance. So 2.22 into inductive reactance value is 31.4. We get an voltage 69.7 voltage. Then the resistance V is equal to, for across the resistor, V is equal to IR. So I effective into R. So 2.22 into 25, 55.5 voltage. So these questions are direct questions, we know that. Then the last subdivision in this question is, what value of the inductance will make the impedance of the circuit minimum? So when the impedance will be the minimum means when the Z is minimum, what is the inductance value they are asking that. So Z is minimum means XL is equal to XC is a minimum condition, that is a resonance condition. So omega L is equal to 1 by omega L, then 2 pi FL, which is equal to 1 by 2 pi FC. Then you keep the L as it is, bring this 2 pi F, so 4 pi square F square C. Substituting these values, we get an answer. Inductance value L is equal to 0.405 Henry. So dear students, this question is a very big question. So this only problem, this third problem alone clearly explains all the problems based on the LCR circuit. So they are asking what is the frequency, what is the reactance, what is the impedance in the circuit, and then what is the current in the circuit, phase angle, then what is the instantaneous current equation. In the question they are giving the applied voltage in alternating voltage value given in the question. Then we have to find the equation for the instantaneous current, and then the effective voltage across the inductor, capacitor and resistor separately, and finally the resonance condition inductance value. So what inductance value the resonance condition will be achieved, at what inductance value the current will be maximum. So we are calculated. So understand this question clearly, it is easy for you.